We will give a high-level overview of the concepts we have covered in this course related to design of experiments for improvement. We will also mention some topics we did not cover. The area of experimental design is fairly broad, and the concepts we omitted can quickly become very mathematical. But if you choose to study these topics on your own afterwards, you'll see that they build on the ideas we have covered in this course. You now have a solid foundation to base your self-learning on. All further advanced experimental tools build on these concepts. We started the course by looking at some basic terminology: factors, outcomes, variables, low and high levels, and so forth. Very quickly, we learned how to interpret, visually, the results from an experiment. That was crucial. A visual interpretation is so important, and not having to run and rely on software. This is a theme we've seen throughout the course. We've resorted to visual tools the entire way: Q-plots to visualize the results, Pareto plots to identify or screen out factors that appear important and those that are not, and finally, in the response surface module, we looked at contour plots to visualize the surface we are moving on. We also learned along the way, at several points, how not to run an experiment. Changing one factor at a time is something we have known for at least the last 8 decades as being inefficient, especially if we want to learn about and exploit interactions to reach that optimum. We learned how to set up our standard order table to assist us. There are 2 to the k experiments in a full factorial, and once that full factorial is run, we saw how to manually create a simple prediction model. Remember that high minus low idea? No software was required. So by the end of the second module, we saw that experiments often have more than one outcome. We might want to decrease pollution as much as possible, but also do so cheaply and obey safety or regulatory constraints. In systems where this is the case, we must either reformulate our objective to include multiple outcomes, maybe by using a weighted sum, for example, or by visualizing the overlapping, competing criteria on 2 contour plots. This visual approach is again very effective. We can see the trade-offs in our system and communicate with our colleagues effectively that don't understand the terminology of response surfaces and optimization. Furthermore, if things change in our system, we can quickly see how to compensate for them. Now, in the third module of the course, we started to use software to speed up our hand calculations. We used a high-quality, freely available tool to do that. The R software has many packages available to extend its functionality. But there are other software tools, and some that are specifically designed for experimental analysis. Feel free to download their trial versions and test them out for your own needs. We liked R because of its traceability in the code. We can always go back and reproduce our results, see where we made mistakes, and even share that code with our colleagues. You might be wondering about formal statistical tools that you might use to make your work more analytical, such as p-values, confidence intervals, analysis of variance, and so on. These are absolutely available and have been there all along in the R output. As you've seen, we've been far more reliant on visual tools though in this course, and less so on detailed statistical knowledge. In the fourth module of the course, we started to look at fractional factorials. We use these when we have a large number of factors, and when we want to practically reduce the number of experiments to some lower value. We know that there's no free lunch and that aliasing will occur, but we have this trade-off table to help guide us in that choice. We learned about blocking for nuisance factors, and we also covered the idea of covariates in that fourth module. I had also mentioned the concept of definitive screening designs, which are emerging as a more effective design than fractional factorials. Perhaps this is a good time to mention the book by Peter Goers and Bradley Jones. That book starts where this course ends. It's a great book written in conversational style that would help you peer into the minds of statisticians as they actually plan complex experiments. They cover topics that many of you have asked about: response surface methods with categorical factors, screening designs, mixture designs, blocking and covariates, as well as the very practical requirements of a split plot design. Those are important topics in practical experimentation, but they go beyond the level we have intended for this course. Those topics build on the concepts we have covered though. Then we started the fifth module of this course: experiments to move outside the region where we started and seek out an optimum. We initially looked at the single factor case, mainly because we can easily visualize that and illustrate the important concepts of noise, model prediction error, lack of fit, and building and rebuilding the model as we go. We applied those concepts to the idea of optimizing in 2 dimensions, and we saw a sequence of videos on the details on how to go about that in the 5th module. Even though those videos were long, they covered some digressions on the practical aspects of dealing with constraints and making mistakes. Now, the response surface idea extends in a natural way to the case of 3 or more variables. We can also bring in the idea of fractional factorials. This will reduce the number of experiments required. The only thing to be aware of is aliasing, because remember, as you approach the optimum, it is those interactions and quadratic nonlinear terms that will start to dominate. You need sufficient resolution at the optimum, and a fractional factorial may not provide that for you. Now, this course doesn't end here. On the website, there are some practice problems to try out. I've also posted a list of resources that relate to the area of designed experiments. If you come across any others, please share them with your fellow students and make a short post in the forums or email me. We'll keep that list up to date. As you might realize now, the topic of designed experiments spans into many application areas. Also keep posting in the forums about how you've used designed experiments. This is a topic that applies to many application areas, which is one of the reasons why we chose to teach this course. So this is the end. I will thank specific people in the credits that follow, but by far the biggest thanks goes to many of you on the forums, both the current and prior students in this course. Your participation and questions have led me to learn so many interesting ways of using and applying experiments. I've made improvements to my own life and career because of it. Thank you also for your feedback. We keep collecting your suggestions and we use them for future iterations of this course. We do ask that you take a few minutes and fill out our final survey. There are 2 simple questions we would like you to answer, and there are a few other optional questions if you have time. So thank you again for your time and your effort. Remember to keep disturbing and observing.